Okay, so we're going to talk about the basic parts of the polynomial. The standard form of the polynomial arranges in terms by degree in descending order. So basically, it's the highest exponent down to the lowest exponent, and the lowest one normally is your constant term. Don't pay too much attention to this part of it. It's a technical part that you'll see further on when you get into larger maths a lot. But you really just understand to write in standard form, you need to write it with the highest exponent and in descending order down to your lowest exponent. And each term is going to be referred to as whatever degree that term is, or whatever exponent is on that term. So if it's x to the third, that's the cubic term, x squared is the quadratic term, x to the first is the linear term, and then the one without the x, the constant, which is what we've always called it. So we have those three that you're familiar with. If anything is a degree of 0, meaning that there's no x, that's a constant, which again we're familiar with. And you're going to name these in two different forms, one from the degree and one from the number of terms, which we've been doing as we go along too. If it's a degree of 1, so the highest exponent is 1, like mx plus b, then it's a linear term. If the highest degree is 2, it's a quadratic term. Those we're familiar with. Now, when we get into a degree of 3, it's a cubic. A degree of 4 is a quartic, and a degree of 5 is a quintic or quintic, tomato, tomato. So after that, it's just a 6th degree polynomial, 7th degree polynomial, 8th degree, and so on. Okay? You're also going to name the polynomials by the number of terms that there are. And so a constant, if that's the only term, it's a monomial. If it has 2 terms, it's a binomial. If it has 3 terms, it's a trinomial. Okay, so this one here is a quadratic, but it's only got 1 term, so it's a monomial. This one is 3 terms, so it's a trinomial. This is a quartic, but it's only 2 terms, so it's a binomial. And any after that, we're just polynomial of 4 terms, or 4-term polynomial, 5-term polynomial, 6-term polynomial, and so on. So I have here, write the polynomial in standard form and classified by degree and the number of terms. So the standard form, I got to put the highest exponent first, 9x squared, then my 3x, and then 5. And I'm just rearranging things. The signs move with the term, remember? So this is a degree of 2, which is a quadratic, and there's 3 terms, so it's a trinomial. So you need to know both those names from the polynomial. The next one is to write in standard form. I have my highest exponent, which is x to the 4th. Then I don't have an x third, and x squared, I have 2 of them. So I'm going to combine these two because they're like terms, and I can combine them, and that's going to be plus 4x squared plus 4x minus 12. So I start with the highest exponent down to the lowest, combine any like terms that are similar, and this is a 4th degree, so that's going to be a quartic. And the number of terms, there's 4, so we're saying 4-term polynomial. So go ahead and try these two and pause it, and I'll give you the answers in 5 seconds. Here are all the parts to these two polynomials. 5x to the 4th plus 3x cubed minus x is a quartic trinomial. And here, make sure you move the negative with the 4x to the 5th. So that's negative 4x to the 5th plus 2x squared plus 13. This is a degree of 5, so it's quintic and trinomial. Okay, so a few things to keep in mind here. When you have a function similar to this, remember that f of x is equal to y. F of x is the same thing as y. Let me say that. You can write it as f of x equals or y equals. But the reason the f of x is used is function notation, because if I want something like this, f of 2, what that means is you're finding the y value, or the function, what the output is when the x value is 2. This doesn't mean f times 2. You're trying to find what the y value is when x is 2. I replace this x with 2. So as you know, what I do on the other side is replace the x with 2 and simplify it. So I have 3 times 2 cubed plus 2 times 2 squared minus 8. So this becomes 3 times 8 plus 2 times 4 minus 8. So I get 24 plus 8 minus 8, which these two will cancel out, and I'm left with 24. So f of 2 is equal to 24. And it's important to understand what that means is that the y value for this function is 24 when the x value is 2. So if you were graphing it, there would be a point on that function at 2, 24, and that point is on the graph. So if I have one like this, what I have to do is I have f of x is equal to this quadratic, and I'm trying to find f of 3c minus 4 minus 5 times f of c. I'm replacing x with those two parts. So I have, let's look at f of 3c minus 4 first. So I'm going to replace the x with 3c minus 4. So I have 3c minus 4 squared plus 2 times 3c minus 4 minus 3. And now it's just to simplify. So when I square this, remember you're squaring a binomial. It's not just the first one squared and the second one squared. You have to multiply by itself. So that's going to become 9c squared minus 12c minus 12c plus 16. And then I'm still combining this part with it. So let me go ahead and distribute that 2. And that becomes 6c minus 8. And then the minus 3 on the end. And now when I combine my like terms, nothing's going to combine with 9c squared. So that stays 9c squared. The negative 12c combine, but with this positive 6c. So when I combine all those, that becomes negative 18c. And then I have this positive 16, negative 3, and negative 8. And those combine to be positive 5. So the first part of this I've done here. And now what I want to do is I want to take that 9c squared minus 18c plus 5. I'm taking that and I'm subtracting 5 times f of c. Basically, that's just 5 times f of x. F of x is x squared plus 2x minus 3. The only difference, instead of the x, I'm going to change it to a c. So instead of writing x, I plug in c for x, and now I can simplify it. So I have this first one, and then I distribute the 5 into that f of x function, or f of c function in this case. So I have 5c squared minus 10c plus 15. Because remember, I'm distributing the negative 5, and now I'm combining my like terms. So 9c squared minus 5c squared is going to become 4c squared. Negative 18c, negative 10c becomes negative 28c. And positive 5, positive 15 become positive 20. and this is your simplified form. Okay, we're going to start looking at the graphs of polynomials. And the first three we should be familiar with. The constant function, when it's just f of x equals a constant, is a horizontal line. And then you have the linear function, which is in that form f of x equals mx plus b. That's a line. And that's the linear function. The quadratic is when it's a quadratic, and that's a parabola. Okay, so from here on, what continues to happen is, if you notice, as the degree increases, what happens is the graph starts to, well, from here to here, you just add a slope. They're both lines, but this one has a slope on it. It's not just horizontal. But when I go to a quadratic, now the graph turns and goes back the other way. And then when I go to a cubic function, it turns once, but then turns again. And then when I go to a quartic function, it turns 3 times and goes back the other way. And again with the quintic function, it turns 4 times. Okay? So there's a few things I want you to pay attention to with these. Okay, so we're going to use n as the degree of the polynomial. And you can find the number of turning points that the graph has by doing 1 less than the degree. So the number of turning points is going to be n minus 1. So when it's a quadratic, that's a degree of 2. There's only 1 turn. When it's a cubic, it has 2 turns. When it's a quartic, it has 3 turns, and so on. And we're going to look at the end behavior of the graph. Now we're going to get more specific with this in a little bit, but I just want you to notice first, when it's an odd function, look what's happening is the graph, the ends of the graph are ending in opposite directions. Now I'm referring to up and down. Okay, so when it's odd, one's going up, one side of the graph is going up, the other side of the graph is going down. So they're going to end in opposite directions. And when it's even, like a quadratic, they're going to end in the same direction. So they're both going the same way. Either they're both going up or they're both going down. And that continues on with the cubic. They're going opposite ways. With the quartic, now they're going the same way. With the quintic, now they're going opposite ways again. And that will repeat as you go further along with the different types of polynomials. Okay, so to get more precise with the end behavior, we're going to describe what the y value of the graph is doing as the x value is going a certain way. So the way we describe that is f of x, remember, is y. So we say f of x approaches, and that's what this arrow means. And it's either going to approach positive infinity or negative infinity. Okay, and that's going to be as x approaches either positive infinity or negative infinity. So let me explain an example. If I have f of x approaches positive infinity, let me write the positive, as x approaches negative infinity. What that means is as the x part of the graph is going towards negative infinity, which is to the left, as the graph is going this way to the left, the y value is going towards positive infinity, so the y value is going up. And then if it says f of x approaches negative infinity as x approaches positive infinity, that means that as the graph is going to the right, which is where x is going towards positive infinity, the y value, or the f of x function, is approaching negative infinity. So it means it's going to be going down as the graph goes to the right. So if you understand what each of those mean, it will make it a lot easier to determine the end behavior of the graph. I'll put up some key important parts, but if I say something that sticks out and I didn't write it down, go ahead and write it down. Okay, So remember, when it's even, they're both going the same direction. That's how you're going to start it. If it's an even degree, they're going the same direction, either both going up or both going down. So if it's a positive, what that means is the two ends are going up. So what that means is as x approaches negative infinity, the graph, the y value, f of x, approaches positive infinity. As x approaches positive infinity, f of x is approaching positive infinity. The y values are both going the same way, and because it's positive, they're both going up. Okay? Where when it's even and it's negative, it means that they're both going down, which means f of x is approaching negative infinity in both directions. You're always going to have as x approaches negative infinity and as x approaches positive infinity. Those are always going to be one positive, one negative. The f of x could be both the same or they could be opposite. So in turn, if it's even, they're both going the same way. If it's odd, the f of x are going opposite ways. Okay, and then you have to decide, is that leading coefficient, that first term when it's in standard form, is it positive? Then they're both going up. If it's negative, then they're both going down. Okay, so this would be f of x approaches negative infinity in both directions. So when we're looking at the odd degrees, if that leading coefficient, the way I like to look at it is just like if the leading coefficient is positive, it's just like a linear, which is a positive slope, and it's going into a positive direction from negative to positive. So as x approaches negative infinity, the y value, or the f of x, is approaching negative infinity. And as f of x approaches, or f of x is approaching positive infinity, or it's going up as x approaches positive infinity. So they're basically, if it's positive, the two are going to match, to where if it's negative, it's going in a negative direction, like a negative slope. Because a linear is an odd function, so it takes up the same characteristics as a positive slope or a negative slope for all other odd functions. Okay, so for this one, we're going to describe the end behavior, determine whether it represents an odd degree or even degree, and state the number of real zeros. So I'm going to actually do this one first, and because they're both ending in the same direction, this is going to be an even degree. And I'm going to go a little bit further than this and be specific with what degree, because it turns 1, 2, 3 times. That's going to be a quartic. Now to describe the end behavior, and I'm always going to tell the left side first and then tell the right side. So f of x approaches, and because it's going down, that's going to be negative infinity as x approaches negative infinity. And f of x approaches, and on the right side it's going down, so that's going to be f of x approaches negative infinity as x approaches positive infinity. As x is going to the right, f of x is going down. So what that means is I have an even degree, and my leading coefficient is going to be negative. Let's tell that too. Because they're both going down, they're going in a negative direction, it means that leading coefficient is negative. And the last part, state the number of real zeros. Well, if you recall from last week, the real zeros are where the graph crosses the x-axis, so there are 2 real zeros. Zeros are where the graph crosses the x-axis, or zeros are where the x-intercepts are. So go ahead and take a second and try this one on your own. Okay, so I've started it. They're going opposite ways. It's an odd degree. The leading coefficient is negative because it's going from positive down to negative. And there's 4 terms, 1, 2, 3, 4, which means it's a degree of 5, which is quintic. The end behavior, I've started it. Try to write it in this form to where the first part of it is going to be as x approaches negative infinity, and the second part is as x approaches positive infinity. So this is as x is going to the left, the y value is going up, so that's going to be positive infinity. And as x goes to the right, or as x approaches positive infinity, f of x is approaching negative infinity and it's going down. And then the number of real zeros, I have 1, 2, 3, 4, 5. Want to hear a pizza joke? Nah, never mind. It's pretty cheesy. Think about it.